Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about the properties of determinants. Right, so this is what we're going to be talking about, the properties of determinants. So suppose you've watched all the first part of determinants in which we introduced determinants to you. So I'm going to be talking about the properties here. So let's talk about the first property of the determinants, which says that if you interchange the rows and columns, so if you interchange the rows and columns, the value of the determinant is going to remain unchanged. So the value of the determinant, is going to be unchanged. Right. So let me show you that in terms of an example. Let's suppose we have a determinant in which this is a1, a2, and a3, and let's say this is b1, b2, and b3, and we have this as c1, c2, and c3. And let's talk about another determinant in which I invert the rows into columns, kind of find the transpose of this in this determinant here. I make this row as this column, and I make the next row as the next column. So this is how we do it. So if we try to find the value of determinant here, which is actually going to be a1, a1 into, so we kind of fix this, then we find the determinant here, which is b2c3 minus c2b3. Then we're going to have minus a2, with keeping this fixed, and we're going to have b1c3 minus c1b3, and then we're going to have plus a3 into b1c2 minus b2c1. And similarly, if I find the determinant here, let's suppose I keep this I keep this one as, just for the sake of convenience, what I'm going to do is I'm going to fix this column here. So I'm going to have a1 into b1c3 minus b3c2, then I'm going to have minus a2 into, so I'm going to have these four values, which is b1c3 minus b3c1. Then I'm going to have plus a3 into, so I'm going to fix this and this, I'll be left with these four values. It's going to be b1c2 minus b2c1, and we can clearly see that these matrices are equal. This value is actually equal to this value. And what you can do is you can actually take up an example of a matrix here, and you can actually verify that by yourself. So let's just take an example. Let's suppose we have a matrix, let's say 2, 3, 4, and 5. So the value of determinant of this is actually going to be equal to 2 into 5, 10, minus 4 into 3, which is 12. That is actually equal to negative 2. And if I find the transpose of this matrix, which is 2, 3, and 4, 5. Now if I find the value of this matrix as well, that is going to be 10 minus 12, which is still going to be negative 2. So that means our values are going to be equal no matter what. So if I interchange the rows and I interchange the columns, if I interchange all the rows with all the columns, my property states that the value of the determinant remains unchanged. Let's talk about property 2. Property 2 says that if any two rows are interchanged, if you interchange, let's say any two rows, if you interchange any two rows, or let's say you interchange any two columns, the sign of the determinant changes. So what happens? The sign of the determinant changes, right? Just write it like this. So if this was determinant earlier, the next determinant is going to be negative of that determinant. Let's put that to test, and instead what I'm going to do is I'm actually going to use let's say I'm going to use an example here. So let's suppose we have a determinant A, which is 1, let's say 2, negative 3, 5, 6, 0, 4, 1, 5, and negative 7. So we have this determinant over here, and what I do is, what I actually kind of interchange row 2 with row 3. If you interchange any two rows. So I'm going to interchange row 2 with row 3, and this is what my new determinant is going to be. Now what do I have to do is I just have to find the values of this determinant. So the value of this determinant is going to be 2 into 0 minus 2 into 0 minus 20. That's 5 into 4 Okay, so 2 into 0 minus 20. Then what I'm going to do is I'm going to fix up this negative 3, but this is going to become positive 3 because this it's second row, first row, and the second column. So this is going to be 7 into 6 negative 42, 4 into 1 minus 4. Then what do I have? I'm going to fix this 5, and this is going to be 30, right, minus 0. So this is what we have. So we have 2 into 0 minus 20. Then we have positive 3 into negative 42 minus 4. And this is what we have. So if we kind of solve this, this becomes 40, negative 40, negative 138, and positive 150, which is actually equal to negative 28. And if we solve this determinant here, this is what we're going to have. We're going to have this 2 into 20 minus 0. Then we're going to have a positive 3 into 3 into, so we're going to fix this. So 3 into 4 plus 42. Then the next one is going to be 5 into 0 minus 30. So if we kind of solve this up, this is going to be 40 plus 138 minus 150, which is actually going to be equal to 28. So we can clearly verify our property, which says that when we interchange any two rows or when we interchange any two columns, the sign of the determinant changes. So let's go ahead and talk about the third property here, which states that if any two rows, so if any two rows or any two columns, if any two rows or any two columns in a matrix are identical, then the value of the determinant is going to be equal to 0. Sorry, let's put that to test here. So let's say we have this determinant here, that is 1, 2, 3, 4, 5, 6, and 1, 2, 3. So let's suppose we want to find the value of this determinant. So we're going to fix this 1. We're going to have 5, 3, 15 minus 6 into 12. Then we're going to have this negative 2 into, we're going to do it like this. 4 into 3, 12. 6 minus is 6. Then we're going to have a positive 3. Then it's going to be 4 into 2, 8 minus 5. So this is going to be 1 into 3 minus 2 into 6 plus 3 into 3. So this is going to have 6 minus 12 plus 6, which is actually going to be 0. We have proved our property here. So suppose you're getting this, that if there are any two rows or any two columns in a matrix which are identical, similarly even this matrix is going to be equal to 0, that is 1, 2, 3, 4, 5, 6, and 1, 2, 3. Even this is going to be equal to 0 because these two columns are identical. So let's move on to the next property, guys, which is let's write it here. So the next property of determinant states that if each element of a row or a determinant is multiplied by k. So let's suppose we have this determinant, let's say this is a, b, c, d, e, f, and g, h, i, and I say I multiply each element of a row or a column by k. So let's suppose I have another determinant wherein I multiply this row by k. So I have ka, kb, kc, and rest of the elements remain the same. So that means it states that determinant 1 is actually going to be equal to k times my original determinant. Let's put that to test here again. Let's suppose our determinant is 1, 2, 3, 4, 5, 6, and 7, 8, 9. And we've already calculated the value of this determinant. It actually came down to be equal to, okay, I haven't calculated it, no problem. So the value of this determinant is going to be 1 into 9 5 are 45, 8 6 are 48, minus 2 into 9 4 are 36, minus 42, plus 3 into 8 4 are 32, minus 35. So if we kind of calculate, the value is going to be 45 minus 43 is going to be 3, minus 2 into 36 minus 42, that is going to be equal to 6. Then we're going to have plus 3 into negative 3. So that is going to be equal to 3 minus 12 minus 9, which is going to be 12, that's going to be negative 18. Right? And what about this determinant here? That is, let's suppose we have another determinant wherein we multiply this by 2 here. So let's suppose we keep it 2, 4, 6, and the rest of them we call 4, 5, 6, and 7, 8, 9. So if we do that, and then if we try to find the value of the determinant here, let's go ahead and do that. So this is going to be 4. This is going to be negative 4 into 36 minus 42. Then this is going to be equal to positive 6 into 36. Sorry, 9 4 ja 36 minus 42. Okay, negative 6 is going to be 32 minus 35. If we clearly observe that we can actually take 2 common from here. So if we take 2 common from here, we're going to have simply 45 minus 48 minus 2 times 36 minus 42 plus 3 times 32 minus 35. And you can clearly see that's just 2 common into the same thing here. This is nothing but the same thing. So that's going to be 2 times negative 18. That means I've proved that if a particular row or a column is multiplied by k, then the whole value of the determinant actually gets multiplied by k. Right? So I suppose you're understanding this property here. Let's move on to the next property, which is property number 5, which states that if I, let's suppose, have a determinant, let's suppose this is a plus k, this is b plus k, and this is c plus k, and we have these elements d, e, f, and we have g, h, i. So let's suppose this is one determinant that we have that is actually going to be equal to, so what we can do is we can actually remove this a, so we're going to have a, b, c, d, e, f, and g, h, i, plus you can actually keep this k here, or even this can be k1, k2, and k3, no problem. So this can be k1, k2, and k3, d, e, f, and g, h, i. Right? So that is what the next property states. So that, you know, whatever element which is added can actually be taken outside, and the value of determinants can be added. You know, let's put that to test. Let's suppose we have a determinant, let's say 2, 3, 4, and 5, which can also be written as, you know, 2 plus 1 plus 1, and 2 plus 1, which, and 4 and 5. So what is the value of this determinant here? So the value of this determinant is going to be 10 minus 12, which is going to be negative 2. And if I kind of write it like this, that is 1, 2, 4, 5 plus 1, 1, 4, 5. So if I kind of calculate the value, that's going to be 5 minus 8. Then this over here is going to be 5 minus 4. So this over here is going to be negative 3 and positive 1, which is going to be negative 2, which is actually giving us to be equal. Right? So I suppose you're understanding this point over here. The fifth property states that if an element to a row or a column are added, we can actually distinguish it like this. Right? So I suppose you're getting this point over here, guys. And let's move on to the next property, which states that if I have a determinant, let's suppose I have a determinant a, b, c, d, e, f, and g, h, i. Right? And what I do is I actually perform an operation here. Let's suppose the operation is that row 1 is equal to row 1 is equal to row 1 plus 3 times row 3. You know, kind of an elementary operation that we perform on determinant. So this determinant is going to be equal to a plus k times g, b plus k times h, c plus k times i. And then we're going to have d, e, f, and g, h, i. Now, how do we kind of break this element? Now, if we use the property number 5, we can actually break it down to be equal to a, b, c, and we can actually break it down to be equal to a, b, c, d, e, f, g, h, i plus k, g, k, h, and k, i, then d, e, f, and g, h, i. We can actually further break it down to be a, b, c, d, e, f, g, h, i, and what we can do is from here we can actually take k out. We can say it's k times g, h, i, d, e, f, and g, h, i, right? So that is something that we can do. And one thing that we already know, that this thing over here is going to be equal to 0. Why is that? Because GHI and GHI is going to give us 0 because two rows are same. So that is actually going to be equal to ABC, DEF, and GHI, which means doing this operation does not change the value of the determinant. Right? So doing this operation does not change the value of determinant. Even if I do it on a row, even if I do it on a column, then this is not going to change the value of the determinant, because I'll get the same value of determinant from where I started with. So this brings us to an end of the properties which are there. I'm going to summarize the properties in a general manner with you. So property number 1 stated that if I interchange the rows and the columns, if I interchange one row with another row, or let's suppose I interchange one column with another column, the value of the determinant remains the same. Second thing was if I interchange, no, sorry, I'm sorry, that was not the property. I'm sorry about that. Let's cut it. Okay, so I'll just write down the properties. So the first property was that if I interchange all the rows with all the columns, the value of determinant remains the same. Second property was if I interchange one row with another row, or one column with another column, the sign of the determinant is going to change and the value of the determinant is going to remain the same. And the next property was that if, so that's the third property. So the third property stated that if any two rows or any two columns of a determinant are same, then the value of determinant is actually equal to 0. And the fourth property was that if you multiply a row with k, or you multiply a column with k, the value of determinant will get multiplied by k. The fifth property was that if you add, let's suppose if you add an element to each row, let's suppose our determinant is a plus k, b plus k, and c plus k. Let's suppose this is k1, k2, k3, and this is whatever it is. Then this is going to be a, b, c, and the same determinant plus k1, k2, k3, and the same determinant. And the last property was that if I perform these operations, that rho I is equal to rho I plus k times rho j, or if I perform this element that is ci, that is ci plus k times c of j, the value of determinant does not change at all. Right? So I suppose you're understanding this point over here, guys. And these are the 6 properties that you can actually use to find out a lot of things about the determinants and do a lot of manipulations there. So, I suppose you're understanding this. Thank you very much for watching this video, guys. And I'll just put it right here. Thank you very much for watching this video. And you can actually explore this website, that is perfect-scores.com, wherein you can ask me questions and explore a lot of stuff. This would be our Facebook page to give us your valuable like, and this would be the email address to give us your valuable feedback. So this would be about this video, guys. Thank you very much for watching. I'll see you in the next.